Alright, in this video, I'm going to help you understand logarithms. Logarithms are the inverse of exponents, so they can help you find an unknown exponent. So let's say we have 2 to the third power equals 8. Well, that's an exponential form. In logarithmic form, we write it as log, and then whatever the base is, in this case, base 2 will stay base 2, but we write it in subscript of 8 equals 3. Alright, so this is exponential form, and this is logarithmic form. And the way I remember to convert between the two is called the circle. And you use it when you're in log form. And you start at the base, so base of 2, 2 to the third power equals 8. And there's the circle. 2 to the third power equals 8. And it'll tell you how to write it as an exponent. Alright, now there are 4 properties in logarithms. The first is called the product property. And what the product property says is if you are adding two different logs, like the log of x plus the log of y, that equals the log of x times y. Alright, so if you're adding two logs, you can condense it to be a single log by multiplying your two log numbers. X times y is xy. The quotient property is for when you are subtracting two different logs. If I had the log of a minus the log of b, that would equal the log of a over b. Alright, so you use the quotient property whenever you're subtracting logs, and your first log number will become your numerator, and your second log expression always becomes the denominator. Now, the most common mistake kids make is that they write log twice, like this, log of a over the log of b. Do not do that. That means something else entirely. So only use one log when using the quotient property. The power property says if your log is being multiplied by a number, like this, the log of x is being multiplied by 2, then you can move that number to the power position, and it becomes the log of x squared, and these are equivalent due to the power property. The change of base formula allows you to evaluate logs. Log base 2 of 8, let me start over, log base 2 of 8 is equal to the log of 8 divided by the log of 2. And if you enter that into your calculator, you will find out that it's 3. And that makes sense because of what we worked with earlier. If you use the circle, 2 to the third power equals 8. So the rule for all of them is log base b of a is equal to the log of a divided by the log of b. So this is when you write log twice. Alright, and the way I remember it is if I see a log, like log base 23 of 9, I'm just making that up. If I look at those two numbers, and there's no variables, meaning I know both numbers, then I quickly rewrite it as a fraction, log of 9 over the log of 23. It's even written like a fraction with 9, the numerator up top and the denominator down below for easy memory. Alright, common log versus the natural log. Alright. Logs are defined by their bases, and some logs are used a lot more than others. All right, whenever a log has base 10, all right, we call that the common log. All right, it's used a lot. And it's so common that you're allowed to write log without writing the base. So whenever you see a log with no base, it's automatically base 10. And when you press the log button in your calculator, you're using the common log. Now the other base that is so common is base E. All right, the natural base, also it's Euler's number. It's like pi, it's a constant. All right, that's so common that it gets its own notation, and it's the natural log of x, which we write as ln of x. All right, so it's just like any other log, except it has a special base, and the base is E. All right, solving log equations. All right, there are several types of log equations. You need to analyze what you've got before you begin. This equation, there's a log on both sides. Log base 4 equals log base 4. Well, to solve this, we use a very simple property. And that says if the log of x equals the log of y, then x must equal y. So if that's true here, then log base 4 equals log base 4, and we can cancel that out. And now, negative 2x plus 5 equals 13. We set the remaining parts equal. All right, and then you want to combine your like terms, subtract 5 from both sides. 13 minus 5 is 8. Divide by negative 2, and x equals negative 4. All right, now you cannot take the log of a negative. You also cannot take the log of 0. But if you plug this back in, you'll see it won't be a problem, because negative 2 times negative 4 is a positive 8. 8 plus 5 is 13, and 13 equals 13, by the way, so that's a check on our work. We definitely did it right. But we also know that we would not be taking the log of a negative, so this is a good answer. All right, on this type of log, there's only one logarithm, all right, not on both sides, so we can't cancel it out. Your logarithm must be isolated before you can begin converting it to an exponential. So this one is isolated. There's nothing being multiplied or divided or added, subtracted. It's just the log. So when you've got that, you can begin conversion using the circle. So 4 to the 4th power equals a. 4 to the 4th power equals a. All right, 4 to the 4th power is 256. So 256 is equal to a, and we've solved it. All right, now this one's a natural log equation, but that doesn't make any difference. Natural log just means it has base e. Now look at this. We have 3 logs. 2 of them are on the left side and 1 on the right side. So the fact that we have 2, that we have at least 1 on each side, means that I can get this to where I can cancel out the logs. But the left side needs to be condensed to just a single logarithm. So we have to use our log properties. We're subtracting these 2 logs, and that means we have to use the quotient property, which says if you're subtracting 2 logs, you make them 1 log through division. So this will become the natural log of negative 4x over 3 equals the natural log of 17. And now it's just like the previous problem. If a log equals another log, well then you can cancel out the log and set the expressions equal to each other. Negative 4x over 3 equals 17. And then simply undo what's being done to x. All right, they're dividing by 3, so we should multiply by 3, which gives us 51, and then they're multiplying by negative 4. So we will divide by negative 4, and we get negative 51 over 4 as the answer. And negative, you can't take the log of a negative, but if you see up here, when we plug that in into the only variable, it's being multiplied by another negative, and a negative times a negative is a positive. So that tells me that's okay. All right, here we have 2 logs on the left side of the equation, but no log on the right. If you don't have logs on both sides, then you cannot cancel, and you're going to have to use exponential form to solve. But first, you must condense down to a single log, and we have 2. But they're being added. So in order to combine those to be a single log, we have to use the product property, which says to multiply. So I'm going to multiply 3 times x plus 8. And I don't want there to be any confusion, so I'm going to put the answer in parentheses so everyone knows that they are together. So 3 times x is 3x. 3 times 8 is 24. And it equals 1. All right, now since there's no base written here, that means it's the common log of base 10. All right, and you can write that in or not, but you can use the circle to convert. 10 to the first power equals 3x plus 24. Well, 10 to the first power is just 10. So 10 equals 3x plus 24. I'm going to combine like terms by subtracting 24 from both sides. Negative 14 equals 3x. And then I'll divide both sides by 3 to solve for x. And x equals negative 14 thirds. All right. Now, negative 14 thirds. Is that going to cause a problem if we plug this in? Now, negative 14 thirds is about negative 4.7. If you plug negative 4.7 in for this x and add it to 8, you will get a positive number, and you can take the log of positive. So this is a good answer. All right. Some exponential equations require logarithms to be solved, like this one. 10 to the r power equals 56. When you have an unknown exponent, you almost always need to use logarithms. All right, well now, just like log equations, the exponent has to be isolated, or the base has to be isolated, and then you convert it. So this will be log base 10, and I like to skip a space, write my equal sign, and then use the circle. So 10 to the r power equals 56. All right, take a step back, look at your work. Recognize that in log form, when you know both of those numbers, you are to use change of base formula, which says that the log of 56 over the log of 10 will equal r. So now we go to our calculator, and we type in the log of 56, close parentheses, divided by the log of 10, close parentheses, and we get an answer. And if I asked you to round to the nearest hundredth, that would be 1.75. So r is approximately 1.75. And some equations are a little more complicated. Like I said, with either log or exponential equations, you must isolate the base or the log. Okay, in this case, we're isolating the base of 13. It's being multiplied by 7, therefore I must divide the 7 away. And 10 does not divide evenly by 7, so I'm going to leave it as a fraction. All right, now the base is isolated. There's nothing else I can do in this form, so I need to switch to log form. So remember, the base is always the base 13. It'll stay base 13. Skip a space, write your equal sign. 13 to the 8p power equals 10/7. All right. Now, again, recognize that when it's in log form and you know both those numbers, you're to use the change of base formula. So this becomes the log of 10 over 7 divided by the log of 13 equals 8p. So calculator time. Let's clear out the old info. Log of 10 over 7, close parentheses, divided by the log of 13. Not 133, but 13. There we go. All right, press enter. Now this answer we get, remember this answer is equal to 8p. We want it to equal p. How do we do that? Well, we simply divide the 8 away. So we divide by 8. And if we round to the nearest 10,000ths, 4 decimal places, that'll be 0.0174. 0.0174 approximately equal to P.